Well, it's been a while since the last video. Been busy doing other stuff around the house. But what I have done recently is just get some little jobs out of the way. With the engine rebuild, need to obviously to replace all the studs because they were very difficult to remove. They're a bit rusty, and a lot of the threads are now stuffed. Like here, these are the cylinder studs that bolt the cylinders to the crank cases. They're a little bit weird in that they have this unusual unthreaded bit at the top, probably just to, when the cylinders are going over the top of these studs, it stops the thread from probably getting marred and damaged. So yeah, they're a little bit unusual. Sure, you can buy all these, but it actually works out quite a lot of money, and I thought, for the fun of it, let's just make some of these up. Also, these are a little bit tricky to track down. The flange ones, I can only get them in a slightly bigger size, in that these are M8 threads, but the across the flat is 12, and for some reason, if you need a flanged on them, they're like 13. So I thought I'd just make up some of those. And these were the cylinder head bolts. They're a little bit unusual. Yes, you can again buy them, but they're not exactly like the original. They've sort of got a flat top to them. And I need quite a few of these, and these actually work out quite expensive. I think it was going to cost me, I don't know, $400, because most of them are pretty banged up and rubbish, so I need quite a few of them. And I thought, if you're making one or two, you just get into batch mode, and you'll see in a minute. I'll just rattle these off, and also it's a bit of a fun project. It's sort of like I'm putting a little bit back into that engine that I made myself. So this video will just follow on how I get these into relatively good condition. So in this section, I'm just prepping the flange nuts in the lathe. So I've already sort of pre-drilled part of it. Now I'm just putting on a slight chamfer. Put another chamfer down the hole just to help with the centering of the drill. And this is a drill that's ready for tap size. And then just chuck it in the mill. I've got one of these handy hex collet blocks, I think they call them, and I'm just machining off the flats to make the hex nut, I suppose. It creates quite a bit of a burr, so it needs a bit of fettling at the end. So again, pop it back in the lathe, just run the lathe tool over it to get rid of the burrs, round it off a little bit, and then part it off. I left a bit of excess gap on the back, because you'll see why in a minute. I machined that flange down so it's a bit thinner. So now I've got got a bit carried away, but now these are all finished. I need to get rid of the little tag on when I've parted it off. So I'll just put a countersink in there, and then we'll face that down to about just over 1 mil, so it's nice and smooth. So that's the next job, and then we can tap them. So next up, we're machining the getting the blank ready for the cylinder head nuts. Just turning down the shank there a little bit. But then I use a finer tool to come in for the finish, just to get rid of the corner radius so it sits flat on the cylinder head. A couple of chamfers, and then we put in the drill, which is a tap size, and just get rid of the burrs, etc. Then just run a tap down there manually. Later on I actually just got the machine to turn the lathe slowly so it's a bit faster. With the tap though, you need to obviously use a starter tap or intermediate tap, and then you want a plug tap, which is one that can run a thread all the way down to a dead stop or blank. So you make sure you get the thread fully formed all the way through to the bottom. And then finally we're just going to part off. So they're all 50% of the work is now done, so they're all ready to go to put the final hex head on them. So I'm just machining the height down a little bit, and then we need to put a bit of a flange on where the hex is going to go. So that's why I'm machining that down there. Put a little bit of chamfer on, and then we can take it across to the mill. Or actually put it in the stop block, collet block. Drop it in there. And just rinse and repeat. So you can see a steel finger there. That makes sure that the collet block goes in the same position every time, so I don't need to adjust the mill at all. And finally we're just checking that the spanner will fit on that nice and snug. Next up, this is a bit tricky. I wanted to put a bit of a chamfer around the flange just to soften the edge off. So I machined up a bit of high-speed steel, and you probably can't see it very well there. There's a bit of a curve in there. It's got an edge already machined into it to give that rounded flange look, and it can get right into the corner there nicely. Next up, there's a bit of a dimple, I suppose, in the top of the nut, so I've just put an end mill in there to machine out most of the metal, and then come in with a small boring bar. A little bit of emery cloth just to clean things up. And we're done. The other thing I'm making up at the moment is some dowels for locate the cylinders onto the crankcases. So there's two that sit either side of the cylinders. The tricky bit I found was the nominal size is the OD is 10mm, but obviously you want it to be a press fit into the crankcase and a sliding fit on the cylinder, because if it's obviously interference fit, taking the cylinders off will get very hard, and you're fighting to get the blooming thing off. And it doesn't have to be too accurate. So I've been experimenting with sizes. So these are all nominal 10mm ODs. Got a bit carried away on this side of the project. I made most of them just 1/1000th of a millimeter under size of 10. So these are like 0.99 9.999 ODs. So they're push press fit into the crank, but just enough wiggle room so you can sort of get them into the cylinder, and obviously you can extract them without too much force. So yeah, I've been experimenting with that. There's way too many of them for what I need. I only need about 4 per engine, so 12 I suppose. But anyway, I'm also going to plate these, and obviously putting a bit of plate on, even though it's, you know, very thin layer, it can actually increase the size a little bit. And so maybe some of the loose, sloppy ones become more of an interference fit. So we'll experiment with that. So next step is just plating them. I mean, they're pretty easy to make on the lathe. They're obviously just a bit of a tube. The trick is just to get that taper on the end, so, you know, engages nicely into the crankcase and into the other end of the cylinder. And also I made them a fraction thicker than the originals. So originals were quite thin, maybe designed so you could crush them and remove them, but I've just made them, you know, 1/2 mil thicker, and I can still get the studs over them quite easily, so it's not an issue. So I'll end up just giving them a quick silver plate, hopefully try and reduce the rusting. These have come out okay. They're pretty sparkly and shiny. So I've got a collection here of slightly different sizes to the thousandths of a millimetre, and hopefully this should be a good, find some that matches quite nicely. I maybe made too many of them, but they're pretty easy to make, so once you're in batch mode you just knock them out. So next up is just a simple job of making up some studs. I got, I think it's M8 or diameter 8mm rod or bar stock, pretty cheap. I just machined down the section that I'm going to run the tap down, because in theory the thread height for the male part of the thread is a fraction under M8. So I looked it up in the machinist handbook and worked out what the diameter is. I think it was something like 7.98 or something like that. But it's a fraction under M8, otherwise the thread height would be too big. And yeah, just pretty straightforward. You rinse and repeat for the various sizes. So this is my little plating setup. Everything is put into drawers, so it's easy to use quickly. So I've just finished the electroplating process, disconnected the cable, and I give them a rinse in plain water. Then they go into a very, very mild solution of acid for about 30 seconds. This is all sped up. Another rinse, and then they go in the passivator colour, and that can be black, gold, blue, silver, you name it. And then they're rinsed and hung up. Now this is a new batch going in. I'm connecting up the power supply to the parts so they get the current go through them, and that's another set ready to be plated. Once the plating's finished, you just have to let them dry naturally in the air. I mean, for silver you can pretty much use them within a couple of hours, but some of the darker colours you have to leave for at least 24 hours. So we're all done. There's quite a lot here, obviously. That would have cost a fortune. I'll flash up how much this would have cost. So I've got 3 engines, so I might as well just do 3 sets of everything. But yeah, they've all come up quite well. The cylinder head, I suppose you call it bolt or nut, depends how your class is. They've come up quite well. Some are black originally, some are just plain old silver. I've got the dowels there, they come up well, and the various nuts for the cylinders on the crankcase. So all in all, that's come up quite well. Is it economical to do it this way? No, it isn't. You probably, if you can afford it and you've got loads of money, just go out and buy them. But like I said, this was more of a fun exercise, particularly making these. Was a technical challenge I like to try and solve, and they came up all right. So it's a win-win in a way. Cool. Now I've got to put the engine together.